Hello, Mornay McCartney here, and I'm doing Excel in simple terms, designing a games. So today we're going to be stepping through the map generation code. I've made quite a lot of changes to the code since our last session, my last video. So I'm going to walk through some of those changes that I've made, show you what I've done. You'll see now when you look at the map, it is significantly different from what we had before. Um, yes, let's jump right into it. Okay, so I decided to get rid of the individual box that was showing you details about your game and what is happening. So at the top you can see I've got my land selectors. So when you've bought a piece of land, you can build a farm, grass, dams, houses, or demolish what's on that block. And then a section to buy and sell land. Not all of these are completely built yet. They are a work in progress. Then I've got my make map, and I've got a button. As I said before in one of my previous videos, I generally, as I build the components, I just put a button on there. So this will be my water equalizer. And that's not going to sit here as a button eventually. It will be part of the game process. It's just while I'm testing it, I normally put a button down, and then I can run that specific module on its own, and I can check that things are working the way I intended. Then I built a little zoom in and zoom out function, and so that you don't have to use the scroll bars on the side, and a up, a down, a center, a left, and a right button. Then I also built, and you can see they work. If I zoom in, it zooms in a little bit closer. You can see 4 squares here which I've bought, and just to show you how it runs. So let's quickly, and then I built a go to button. So eventually this will be part of your gameplay. Obviously you've got your map, and then you've got your court. And your court will tell you a little bit of stats of your population, the workers that you've got, the production that you have, the land, and a little bit of what you are doing on your land. And this is where I will be running my turn from. Or I may not. I think I may actually leave it on the top, on the toolbar. So to show you, we basically, if you generate the map, oh, I think I'm in some code that's started to run. So let's just stop my code. Just want to alt it. So I'm going to jump back to the map. So looking at the map, you can see you can scroll right, you can scroll left, you can center the map to the center of your world. You can obviously zoom out, and let's center it. So the center is not working perfectly yet. I basically got it, I used a formula to just select the center of the map, but it seems like it's scrolling you to the end of the map instead of to the center of it. So there's a little bit of work that still needs to be done. Let's generate a map. So at the moment you can see it's running through every line and showing you which column and row it's busy working with. Eventually we'll take that away because it does eat up a little bit of the speed of your map generation. You can see the map is flickering the whole time, and that is because it is refreshing this every time. It's repainting this block or your toolbox every time that it is updating the information here. Because we switched off spreadsheet updating, so it will only update the screen at the end of running through that specific module, and you basically have to repaint this toolbar every single time, every change that you make. So you'll see in the next section when it starts, after it's generated the map, it's going to start by painting in the individual sections in the interior of it. You can see my 4 blocks are still highlighted there at the moment. it's going to change that because it's changing the ownership of all the blocks to 0, which is no player's land. So now you can see it's stopped flickering because it's only updating that it's generating land, generating rivers, so you don't really see the flicker. So we want to avoid that in the front section of the game. So eventually we will take away those blocks. It's just at this point that I know what it is busy doing and where it is, and if it gets stuck, that I know where to go and look for the problem. So the map generation is working fine, and if we scroll in, and I decide I want to buy a certain piece of land, so I can select that and I can say buy land. It says, ask me whether I'm sure that I want to buy the land, and I say yes. And that land is now surrounded by a red square, being my land. It tells me you bought 1 acre of land at 100, and your treasury is 127. So those numbers are all coming from your inner cheat. You can see I've got a treasury box there. So obviously if I change that to 5,000, I go back to my map and I buy another piece of land, you will see that it updates the amount that I have in my treasury. Now, the way I changed the message box was basically I created one single block so it's a single message that sits here, and it takes 2 messages and combines it. And then I created an option to also speak out the words, which you can hear if I go and set that wording to true. And I'll show you that function. So let's close this, and I want to switch to my Visual Basic. And you can see if you look at the speak function, I think I called it send message. Just wanted the message sender, and it's called send message. So I have a little application speak and message. So if this optional speak as Boolean is true, it will say speak it out, and if it is false, which is the default, because if you don't put an option in there, it will automatically assume that it's false. Then it will not. It will just display it on the screen. So we can use that later on in our game by just setting things as true, and it will say if we can get the game to speak to you and audibly. So as you can see, there's been quite a few changes to the game. I split almost all my modules up. I'm still in the process of putting option explicit in all of the modules and defining every single variable, so that still needs to be done. The general beginning, that is where my game will start. This will be the loop that runs in the background and constantly updates your tiles with what other players are doing. Then the choose 1 of 10 we've run through. So that is basically where we give we have 10 possible options, and we give a percentage as to the chance of that specific option being the correct option. So it's when we want one possibility to be kicked out by the program, and we want to, if we say we give 10 different possibilities, but we say chance A is 10% and chance B is 10% and chance C is say 50%, then of those 3, chance C is the most likely to be kicked out. Then we've got one section here that is just the count records. You can see I have creature in there. It was because in my previous game, this is a module I copied. You'll see that all these modules are written in a way, so I can literally just copy this module and paste it into my new program, and voila, I've got a module that runs. Then the dice we've run through, I've made one change to the dice, and that is I've put an option in it that allows negative numbers. So you could put a negative minimum dice in, and it will kick out the correct number. So the way it does that is, say for instance you want a number between negative 100 and positive 100. It's going to take 100 plus 100, because the built-in Excel function for generating a random number only generates positive random numbers. So it will then generate a number between 1 and 200. However, it will deduct 100 because you've got a negative 100 possibility. It will deduct the 100 from that number, and if for instance you threw a 5, minus 100 will give you minus 95, and that is then the number that it will produce. So it will allow us later on in the game to be able to just generate negative numbers when we need a negative number for something. Then file controller is basically my plan for being able to allow this game to be played via somewhere on a local area network. You could probably play it outside of your local area network, provided the location where you store these files you can share. I have used WebDAV in the past, and it works quite well to be able to basically map that network drive between multiple machines, and then so what this module does is it will go and make a copy of every single tile in your game. And it's going to create these little sections. So this is for all your your different map tiles. So for instance, you've got one that is your ownership, and you can see there's a file that represents every single cell in it. So look, it generates quite a lot of files, but they're all 1 kilobyte files, because it only stores what the value that is in that specific file. So you're looking at about 10.5 meg per map tile that's being generated. So you can see that because I've got quite a few, you're looking at about, let's say, 100 meg here. It's not a lot for a game, and they're all 1 megabyte files. It doesn't take very long to generate because of this files are tiny. So basically what this will do is when I end my turn, it will go and write to my grid, and it will go write the changes I've made to these files. The other player's computer will then, when it starts its turn, will go and read all these files and update its grid. And your computer will likewise do the same. When it starts your turn, it will go and read what the changes the other players made to these files and update your grid. There's still one little issue that I need to sort out here, and that is file locking. You'll see if you run through the code, you'll see there's nothing that prevents two people from writing at the same time. So we just need to build a little control in to make sure that the last change that is saved to this file is it basically saves it in order of when those changes have been made. But because of the small size of the file, the chances of two people in a normal network setting at home or is going to open the same file at the same time is quite small. So we're going to build in some locking method to just allow it to wait a moment if the file is locked. And I mean, it literally would be a microsecond, because it is, because of the size of the files that is quite small. But essentially, we're doing the same for every single one of our grids. We've got a little population grid, unemployment grid, your rats and your locusts, your criminals, your grain, your things like your tile terrain. And when you look at these files, you'll see if I open the file, it will just have the name of the tile of what's in this. Now I haven't. This was run quite. The update to these files were run quite a bit, so you'll see it still says Ocean 1. In the meantime, I have changed my Ocean wording as well, and the reason why is because when I generate my map, the method that I'm using creates little blank spots in here. So I don't want it to be called Ocean. I want it to be called Deep Water. And then my rivers and things will be shallow water. So this is these ones. That's the rivers that it's drawn in. And yeah, so you'll see in those files, it is still, it's not linked to the program just yet. So at the moment, it is still when I initially created that module. So the file controller is straightforward. It basically goes and looks at what you want to write to each one of these individual folders. It goes and it has a sheet location, which is the reference to the actual sheet. Like for instance, your map terrain that will be for your map terrain, and it will be the message that it will send out will be updating map terrain. And then it goes and it's got a sync read and a sync write. And this is the file manager that basically just says that it is going to be in write or read mode, and runs through the files and updates them. And likewise, if it reads the file, it will update your grid from those files. And then this section is just, I created an X option to be able to kill my files, which obviously in your normal gameplay you're not going to do that. You will want to just create the files and read the files. But I created those options because, as I said before, I create my modules always with the intention of being able to use it in other places. So you can see that this has application in many other areas. I mean, you could, anybody who's worked with multi-user files in Excel before knows that it creates problems. That when multiple users try and write to it, it will ask you which of the options win, which of the cell changes win. If there's more than one player or more than one user that made a change to those cells, and then you have to try and figure out whose change is more relevant. So we will have to manage that in this with a little module that just makes sure that the last change that was made is the relevant change. So that we will still need to develop. Then this is obviously my grid controller, the grid controller to read, and that is just to keep, as you saw, we used read grid quite a lot in our program, and the same with write grid. It just basically goes and updates the information in your grid, or so either in the cell itself or in a cell north or south or west or whatever direction around it. And that we drive through here. Then at the moment these are still sitting in this module. I will be separating them, but for the build cost, I've got a little module here that just basically goes and updates, goes and looks at your grid. So as you build onto a tile, it increases the value of that tile, and that is the basis of when you buy or sell a tile, what the charge would be. And then refresh map borders, that's just to draw the little border around your tile when you buy it. This and the mark borders section. And essentially you can see the way it does it is it's literally just taking RGB values, and then it goes and updates the RGB values of that border. So I decided to use RGB because then you can get to exact colors and you can actually represent a player with a color that makes a little bit more sense. It makes it easier to pick a specific red, a specific green than using a color code that Excel generates, which I must be honest, to this day I cannot figure out when I want a specific color, which color code to use in of the Excel code. So RGB works better for me. Then my graphical user interface, this literally just so it's, I call it GUI update off and GUI update on, and it just stops screen updating and it stops auto calculations to speed up the process of when we are updating maps and things. then your message sender that we ran through earlier. Then I've got my round earth location. So basically when a value, if we are looking at, for instance, a value, a cell value of row 1, column 1, and it becomes -1 on your row, I want it to go to the bottom of the map. Basically then to row then becomes 101, because if you pass row 0 to Excel, it won't know what to do with it, and you'll get an error. So this is just basically to create that round world. Then I've got some defaults that I've set. They will need to be reworked because I've made quite a lot of changes since I started with this. Then I've got my table controller, which is basically anything that's not a grid, where we want to be able to read, like your init table, for instance. So that controls it, and this section just helps. It's a helper to this function, just to be able to identify the row and column that we're referring to. If you remember, in this we basically pass it a name, the name that we've put into the column and the row, and we wanted to identify the column and the row, and then go and either read the data from there or write it to there. Then land market module, we basically have, this is where our buying of land happens, and so it kind of just checks whether another player owns the land yet, because you cannot buy land that another player owns. We will build a module that you can eventually, that has a little market where you can buy from another player, but at this point it basically just looks at whether the land belongs to anyone, and if it doesn't belong to anyone, it allows you to buy it. Then my nature general. So nature general is basically a module that's going to run every turn, and that is going to manage our basically manage nature. It's going to change the temperatures for the different blocks, or the different tiles of our map. It's going to determine how much rain there is, and the way it's going to determine the rain is by moving water around. So I've got two, if you look at my Excel sheet, I've got two tile grids there that manages water, so we can have a look at that. The one is going to be what I call sky water, so that's any evaporated water from the ground. So every turn we will calculate how much water, based on the temperature, is evaporating into the sky. And then I've got another one that says that is just called water, or I think it's called groundwater, and that is basically how much water is in the soil, because if there's no water in the soil, then obviously nothing can evaporate. And so those two together will determine how much water is in the sky. I will then have wind that moves the water values from one tile to the next, and when it accumulates to a specific point, a point that I haven't determined yet, I'm still working on that, then it will rain on that tile. So kind of we're going to try and build kind of a weather system that is a little bit more realistic. As water evaporates and the wind blows it, it will accumulate in certain spots, and we'll allow the tiles on the ground to also influence it. As we all know, when the wind blows water that in the air, clouds, and they hit a mountain, for instance, your likelihood of it raining at the mountain is much higher. So we're going to consider what tile is below that sky water as well. Then jumping back to our module, so the next section, then I've created this, but I haven't put any code in it, and that is my tax collection, and that is going to be managed by how many people you have in a specific tile, whether they're employed or unemployed. I'm going to look at whether there's criminals there, and then we've got a section that is, so my sky water also have nothing in that yet. Oh goodness, sorry, I'm looking at the maps. So we were down here at Landmarket and we looked at Nature General. Okay, so Nature Rain, I built a few things there yet already, but we're not quite at the point where I am happy with how the rain is calculated. Um, Temperature, I have no code in yet. Water equilibrium, this is basically where I'm going to decide how my tiles, how my water in nature is moving. So water equilibrium will be moving water on two levels. One is the groundwater because it's going to move slowly from a high altitude to a lower altitude, and that will also kind of generate rivers on the fly. If it rains a lot in an area, you will have some rivers and you will have some flooding. And then wind, I don't think I've got no code in there yet. Ownership is quite straightforward. At this point, it's just a function to determine who the owner is of a specific tile. Population, I've started building some things in there to determine population, but this is really just functions to write the values to the grid in a specific place. Then my forest. So this is all the components that I created for my map generation. So it's a kind of look. This is basically alphabetical. So it really starts at general. General calls all these other modules in order to generate the map, and it is quite straightforward. It basically just makes a water map, then generates the land on it. With a little module that just calls specific portions of the other code that's in the map terrain and whatever the section is that it's calling. Make River is basically a stepping program that it selects a point somewhere in the map in a specific area, and then it places a tile, and then from that it steps slowly but surely towards the ocean. The moment it reaches ocean, it stops generating. So I created this Make River. I created with this piece of code. The code basically starts with 4 options, and that is basically my 4 directions. And then it decides. There's 5 options. The 5th option is basically to go back on itself, and there's a very small chance that it will go back on itself, because essentially I never want my river to run back on itself. What I'm trying to avoid with a river running back on itself is, let's say I'm running through 50 iterations of this code. If the river constantly changes direction back onto itself, it's literally just going to place one single water tile, or maybe 2 or 3 single water tiles in and around it. That it will basically be oscillating between the 2 values and never going anywhere close to the ocean. So I'm trying to avoid that. I basically said that I used select case, and I said that if the value is within the first 24 of the 100 dice that it throws, it will go in a specific direction, but it can either go, say the river starts and it moves north, then it's more likely to move north, east or west than it is to move south back on itself. So that's basically what I did with this code, and you can go and have a look at the code. It's very straightforward. I basically created all the directions, including the side directions like northeast and southeast and northwest and southwest, and then I basically just put the dice 5 option is basically just to change direction. So I said if the chance is very small of it changing direction, it's more likely 24% is the likelihood of it moving in a straight line, and 24% is the likelihood of it turning either north or east if it was going north. And so if it does throw dice in that 4%, then it will change direction. And as you can see on the map generation, it does work quite well. It kind of follows a specific direction until it gets to the ocean, and just kind of meanders off a little bit to the sides. And so I'm quite happy with the map generation. It can be still tweaked a little bit, but essentially I'm happy with what it generated. Sand is is basically the first step when it generates the land, and that is, as I explained in my previous video, it basically uses a spiral method. So it places a point somewhere on the map in the water, and then spirals out from that, based on a dice throw. So if the dice was 8, it will spiral out from that center point, clockwise, only 8 blocks. So it will literally just generate the center point, the point above it, the point next to that to the right, point below that, and so it will continue in a spiral shape, and place that block. And then it will repeat that, I think I set it to somewhere between 300 and 500 times, and that's why we get a map that's not square, because it's basically creating these tiny little spirals that overlap in places, and it's doing that quite a few times. And you can see although there's always a lot of comments about how slow Excel is in generating something like this, you can see that it is not much slower than what you see in many other games out there. Obviously, we're not generating the kind of graphics that you are experiencing in other games, but it it's but what we're building here is an Excel game. We're not using C or some much faster language, so I think it is quite adequate for our purposes. Soil obviously is a random thing that just gets placed in a specific tile. It's very straightforward. Then verify buildable, that is when you decide to place a tile on, or let's say we want to build a farm. Obviously we cannot build it in the middle of water. The farm needs to be on land, and it can't be on a mountain, can't be on a hill. So what this basically does is it goes to my spreadsheet, and on the spreadsheet I've created on the map lookup. So I just want to see where's my map lookup. On my map lookup we have, oh my goodness, no, I can't see it. Where is it? Let's quickly have a look. It is here somewhere. There, map lookup. So I basically said that, so what I did is I said that a dam cannot be built on another dam. So you can see it's kind of a cross-reference between this value and this value. I mean, it makes no sense to place a dam on itself. And you can see at an angle we're going with falses, and that is basically to avoid the same thing being placed on the same tile. And then we said certain things cannot be built on other things, like for instance a farm cannot be built on a dam. Grass cannot be built on other grass, and grass cannot be built grass cannot be built on sand, because I don't want it to be built on a beach. So these rules you can decide for yourself, and then certain things we do want to be able to build on each other. Initially I wanted to make sure that you demolish the tile first before you build something else there. So for instance, if you built a house, that you had to demolish it. But I decided that to allow certain things to be built on top of each other, and what this module will actually do is there will be a cost involved. So it will be, when you click on, for instance, a house and you want to build a dam on it, it will first charge you the cost to demolish a dam, which is 25% of the cost of the dam. And I've basically worked on 25% straight for all the tile structures, just to avoid having to build another table that with values on it, of the percentage that you're getting charged. So, and then it will charge you for the next value that is being built on it. So verifiable will just check whether it can be done. Then verify, do I own it, is straightforward. It just checks whether the tile belongs to you. And verified placement will then go and calculate that demolishing cost and the construction cost. And that is basically the code that we've written so far for this, except the only other place where we put code in is in our toolbox. And just clean it up a bit here. So just want to remove that space. And this is also straightforward. Genesis is basically when you click the button to make a map, and that will just call make map. Make map will then decide the message that's being sent. A lot of these modules are kind of mixed in here at the moment. I want to move them to their own module, but I just thought for now, because they relate to what is shown in the box, I've just left them here. So you can see we've been busy with this game for quite a while. Game is a lot of work. It does take a lot of time, and you can see that we are nowhere close to finish with it, but we have made considerable progress. You must consider that normally it takes a team of people to work on a game. You are obviously one person, and so am I. So it's going to take us a while to finish this game, but we are going to learn valuable concepts while we're doing this. And you're going to see in these modules, there's stuff that you can use in many other places. Things like being able to read and write the grid can be used in any other application that you are building. So they are, a lot of the modules are general purpose modules that can be reused. Things like the dice, you can literally copy and paste this module out of here and paste it in any other thing that you want to use where you want to use a dice throw. And the nice thing about this dice with being able to generate the negative numbers, I mean, it's very handy. Honestly, I never knew how to do this. I didn't even think of just minusing the amount. And then I sat with a piece of paper and tried to figure out how can I generate a negative dice. So this you can use anywhere, including in your actual Excel spreadsheet. Because if you don't know, when you create a public function, you can go and call it directly from an Excel spreadsheet. So just to show you, so we can say equals dice, and I can say minus 5, comma 10, and it will kick out a value. And if I refresh it, I'll get an 8, I'll get a 1, I'll get a minus 1. So you can, that's the nice thing about being building functions. It is very handy. So I come out of the banking industry, and I used functions a lot to build my own custom formulas, and yeah, even in another industry where I used to work in the motor industry, I used to build functions to calculate things as taxes, your import taxes, things like ad valorem duty. So instead of having to build a little spreadsheet every single time that calculates it, I would just use my formula. And I will, at a later stage in my training videos, also show you how to actually create those formulas as add-ins, so you don't have to copy and paste it into every single spreadsheet that you do. You can just create an add-in, and you can use it anytime you open Excel. The only proviso is that if you give somebody else your spreadsheet with your formulas in, they also have to have the add-in. And that is the downside of it. So generally I rather build it into my spreadsheet than I create an add-in, because unless it is only for my own use, in that case the add-ins are fine. But if you give it to somebody else, it will not calculate dice with a negative number if you give them the spreadsheet and you don't give them the code for it. That specific piece of code. So best practice is rather to embed it into your spreadsheet, because then you know when you send the spreadsheet, the function is already in it, and it will run as long as the spreadsheet is saved as an XLSM file, or an XLSB file. The difference between XLSM and XLSB is just that the one is a binary file, but essentially it does very much the same thing. And when your spreadsheet starts growing quite a bit, you will see that an XLSB file will probably be a better option because it does make the size considerably smaller. So this is basically it for the run through of the code, and we're going to start tackling specific playable matters in our game. But I think in the next module we're going to look at the weather system, and we're going to start building on the weather system and getting that into a state where we can start moving water around in our world, getting the temperatures to move and the wind direction to change, to move rain to where it kind of want a random method without just randomizing it. We kind of want that random aspect of it, so that you have rain in certain tiles, but we want to follow some kind of logical pattern, because the idea that I have is that I want certain areas to get drier and drier as time goes by because they don't really get a lot of rain, and certain areas to just be lush. So what I'm basically going to do is my rainfall I'm going to link to the type of tile. So if you haven't built a house or a dam or something on a tile, and for instance there is sand on that tile and it rains a lot, it will eventually start turning into grass. And if it rains more, it will eventually start turning into maybe a forest. And that is what I have in mind with this. So the map will kind of regenerate itself as the game progresses. And the longer you play, the more changes your map will undergo. So that is it for this video, and I'll see you in the next one. Thank you very much for watching the video, and if you enjoy the video, please like and subscribe. And please visit my website, bringmesome.co.za, to download the code. And also you will see a link there to all the videos, so they're all together and in order. Finding the videos in YouTube is sometimes not so straightforward because they don't get grouped together and in order. So it's much easier from the website to click on the videos in order if you want to follow it in the order that I wrote it. Thank you very much and have a nice day.